Okay, and next we're going to talk about the concentration in parts per million or parts per billion. So when we're representing very small concentrations, like concentrations of drugs or concentrations of just very small materials in a large amount of solvent, these units are very good for, very handy for calculating concentration. So the first one we're going to deal with is parts per million. To calculate parts per million, we're basically taking the mass for every 10 to the 6, for every million grams of solution. So the number of grams of solute for every million grams of solution. Okay, so the easiest way to calculate that, to get parts per million, you're basically taking the percent mass, the mass of solute divided by the mass of the solution, and multiplying that by 10 to the 6. For parts per billion, it's kind of the same thing. We're taking the number of grams for a billion grams of solution. So to calculate parts per billion, we take the mass of the solute, divide by the mass of the solution, and multiply by 10 to the power of 9. Multiply by a billion, basically, to get our parts per billion. Okay, here's a simple example we can use. So a fungus that grows on peanuts produces a deadly toxin. When ingested in large amounts, this toxin destroys liver and can cause cancer. Any shipment of peanuts that contains more than 25 parts per billion of this dangerous fungus is rejected. A company receives 20 tons of peanuts to make peanut butter. What is the maximum mass in grams of fungus that is allowed within this sample of peanuts? Is basically the end of the question there. Okay, so parts per billion, which is what we're referring to in this question, is equal to the mass of the solute divided by the mass of the solution multiplied by 10 to the power of 9, basically multiplied by a billion. Okay, and in this case we can't go over 25 parts per billion. We can't have any more fungus than that in the peanuts, or it will be deadly to people. So we put in our 25 parts per billion is equal to, and they're asking what mass of fungus is allowed within this sample of 20 tons. So we're going to say mass here, that's our variable, divided by 20 tons. Okay, now we need this in grams because parts per billion is in grams per gram, per billion grams, basically. So 20 tons times, and I know that there's 1,000 kilograms per ton. Okay, and I need it in grams, so I can also multiply by 1,000 grams per kilogram. Okay, and then multiply all that by 10 to the power of 9. Okay, our mass of our fungus can therefore be no greater than 25 parts per billion divided by our 10 to the power of 9 and multiplied by 20 tons times 1,000 times 1,000. And that works out to be 0.5 grams. So any more than 0.5 grams in the 20 tons of peanuts, and we'll have a parts per billion that's over 25, and that won't be acceptable for importing those peanuts. Okay, we're now going to talk about the last way of representing concentration, and that's by using what's called the amount concentration. Okay, and we're going to use this way of measuring concentration throughout the remainder of this unit. So this is maybe the most important way of calculating concentration. Amount concentration is in moles per liter, and we calculate it by taking the amount of solute in moles, so the number of moles, divided by the volume of the solution in liters. Okay, so this is totally different, moles per liter. convention is convenient for chemists to measure the number of moles involved in a chemical reaction, definitely. These symbols often get used as we're going through our calculations. So C represents the amount concentration, N represents the number of moles, as we already know, and V will always represent the volume of the solution. So here we go with our first example. A saline solution contains 0.9 grams of sodium chloride dissolved in 100 milliliters of solution. What is the molar concentration of the solution? Okay, so C is equal to N over V. So let's start by trying to find our N. We have 0.9 grams of sodium chloride. So N is equal to, luckily we already know how to do this, 0.9 grams divided by the molar mass of sodium chloride. So that's going to be 22.99 grams per mole, plus chlorine 35.45 grams per mole. Okay, dividing through, we find that we've got 0.0154 moles of sodium chloride in that 0.9 grams. Okay, so calculating the oh, and then you know what? We can't use this 100 milliliters for our volume as it stands. The volume is going to be, yes, 100 milliliters, but as we were saying, we need our volume to be in liters, so I'm just going to multiply by 1 liter divided by 1,000 milliliters, 1,000 liters, milliliters in a liter, so that's going to give us 0.1 liter. Okay, now that we know the number of moles, we know the volume in liters, we can go ahead and make the calculation of the amount concentration. Okay, so C is equal to N, which is number of moles there, divided by our volume, 0.1, gives us 0.154 moles per liter. Okay, and that is our concentration of the saline solution. Okay, we're down to our last example for amount concentration. A last example of the lesson here now. It is at 20 degrees Celsius, a saturated solution of calcium sulfate has a concentration of this number, 0.0153 moles per liter. A student takes 65 milliliters of this solution and evaporates the solvent out of it. What mass in grams is left in the evaporating dish when this is finished? Okay, so let's see. We've got our equation. C is equal to N over V. And we know the amount concentration. Okay, so there's our C, and 65 milliliters. Okay, that's our V. And they're asking us for mass in grams of calcium sulfate. Okay, so that's going to be found after we can determine the number of moles here. Then once we multiply that through by the molar mass of calcium sulfate, we'll be able to solve this thing. Okay, so we've got our C, we've got our V. Actually, our volume is in 65 milliliters, so let's just quickly convert that over. Our volume here is 65 milliliters, okay, times, and we want it in liters. There's 1 liter for every 1,000 milliliters. Okay, so 65 milliliters is 0.065 liters. Okay, so we've got our C, we've got our V. Let's go ahead and calculate our N. Rearranging this equation here, we can say that N is equal to concentration times volume. So let's plug those numbers in. C is 0.0153 moles per liter. Multiplied by, okay, we've got our volume. It's going to be 0.005 0.065 liters, and multiplying that through, we get 9.94 times 10 to the negative 4 moles, right? That's what we're calculating, the number of moles. Okay, so there are that many moles in a solution with this concentration, 0.0153 moles per liters, and this much volume. That's how many moles we get out of it. The mass of that is just going to be multiplied by the molar mass now. So the material, again, was calcium sulfate. So the mass of calcium, CaSO4, is going to be our 9.94 times 10 to the negative 4 moles times mass of calcium plus mass of sulfur plus 4 times mass of oxygen. Okay, grams per mole. And that works out to be 0.135 grams. Okay, so that's our lesson on concentrations. Hope you'll be ready to come to class and do a couple of great examples, answer some quiz questions, and we'll see you there.